Hello everyone, I am Amit Kumar, Assistant Professor in IT Department. Today I am going to give an brief introduction about the secondary storage scheduling, that is also known as the disk scheduling, and it is comes under the last part of the operating system. So these are the outlines of my today's topic, that is disk scheduling and disk management. How we are doing this disk scheduling and what are the algorithms for disk scheduling, and how we are managing these disks in the formats. So I am going to discuss in this PPT. Next, what is disk scheduling? The operating system is responsible for using hardware efficiently for the disk drives. This means having a fast access time and disk bandwidth. Means we have the fast access time for the using for the CPU time and the disk bandwidth, that where I am going to store my data. So it is going to be a big bandwidth for that one. Access time has two major components, that is seek time and the rotational latency. So what is seek time? Seek time is the time for the disk disks are to move the heads to the cylinder containing the desired sector. Means it is the time where the disks are to move in the heads for the cylinders. Means the heads, these are the here the disk are stored and head is like this and it is moving like this. So the where the disk are moved to heads to the cylinders containing the desired sector, in which sector the disk has been this moving. So what is the time for that one? That is known as the seek time. Rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. And third is minimize seek time. We have to, in this scheduling we have to minimize the disk seek time. Seek time is approximately the seek distance. Disk bandwidth is the total number of bytes transferred divided by the total time between the first request for the service and the completion of the last transfer. Disk bandwidth is means the total number of the bytes transferred divided by the total time between the first request for the services and the completion of the last transfer. This is the disk bandwidth. Now, several algorithms exist to schedule the servicing of disk IO request. There are so many algorithms. There are such algorithms where we are having to get the disk services. We illustrate them with a request of a queue. For algorithms or for the disk scheduling algorithms, we have took some request queue, that is 0 to 199. Means the data has been given is 1 to 200. But we always start from 0. So 0 to 199 is the request. So these are the requests: 98, 183, 37, 122, 14, 124, 65 and 67, and the head pointer is 53. Means the head pointer is 53, means the request is going to be start from the 53. Now the first scheduling algorithm is FCFS, first come first serve. So as the queue has been given for this one, and I have told you that we are taking 0 to 199 the disk. So for moving 640 cylinders, total head movement we have to show that. So how we are going to complete this one? So the queue has been given 98, 183, 37, 122, 14, 124, 65 and 67, and the head is started from 53. So we have taken the disk line and we have took this one 0 to 199. So disk has been started from 53. The head movement is started from 153. So first come first serve means the value which has been come first, we have to take that one. So after the heading is started 53, we are starting from 53 and the first value is 98. So it has been gone from 53 to 98. Next 183. So it will go into the 183. Next 37. This will go into the 37. Next 122. 122. 14. 14. Next 124. 124. Next 65. 65. Next 67. 67. So this is the path where we have going to be do for the disk scheduling for the first come first serve. So we have to find the seek time. So finding for the seek time, the value couldn't be the negative value. So for finding the seek time, we will have to take the positive values. So for that one, we will take the highest values first and we have to reduce that one. Means 98 minus, first 98 minus 53 plus 183 minus 98 plus 183 minus 37 plus 122 minus 37 plus 122 minus 14 plus 122 minus 14 plus 124 minus 14 plus 65 minus 14 plus 67 minus 65. And if you will calculate this one, then that will be the total seek time for this first come first serve. Next is shortest time first. Okay, so shortest seek time first, SSTF, shortest seek time first. Select the request with the minimum seek time from the current head position. We have to take the minimum time or the minimum seek time from the current head. SSTF scheduling is the form of SGF scheduling, may cause starvation of the some request, because if it will go through that one, it will be it will cause a starvation. Illustrate showing the total movement of 236 cylinders. So for the SSTF, we have taken the queue same as, and the head start from 53. So that one, the explained, I have explained, that is first come first serve, and this will be in the shortest seek time first. So for that, we will take the minimum, as I have told you, the minimum seek time for the current head. So for this one, we have took the queue of 98, 183, 37, 122, 14, 124, 65 and 67. So and the head movement is 53. So which one is nearest from the 53? That is 65. So it will move into the 65. Next 65 nearest, 67, 67, 67 nearest in this all, that is 37. Then it will be moved into the 37. Nearest for the 37 is 14. Next after the 14, no one is nearest from that one, so we will move right direction for that one. Now 98 is the nearest for that one, 98. Which one is the nearest for 98? 122, then 124, and after that 183. This is the path, and we have to calculate this total seek time. So seek time would be, now you will have to reduce all these one as we have done in the previous work. That is 65 minus 53, 67 minus 67, 67 minus 65, 67 minus 37, 37 minus 14, 98 minus 14, 122 minus 98, 124 minus 22, 183 minus 124. This will be the, if you will calculate, if you will subtract it, you will get the total seek time for SSTF. Now scan. The disk arm start at one end of the disk and move towards the other end, servicing request until it gets to the other end of this disk, where the head movement is reversed and servicing continues. Sometimes it's called the elevator algorithm. Sometimes it's called the elevator's algorithm for the scan. Illustrate the total head movement of 208 cylinders. Now we are taking for 208 cylinders, and this is the scan, and where the queue has been given as same as that one, and the head starts from the 53. So as I have told you, it will start from one end and it will go to the one end, and after that it will go into the another direction. Okay, and another end. So the head is start from 53. So if we will move in the left end, so for the left end, the nearest of 53 is 37. So it have moved into the 53 to 37. Next 37 to 14, 14 to 0, because it has to be end. If you are taking in the scan, it should be go to into the end part. So it will be for the 0. Next it will go to the 65, then 67, then 98, then 122, 124, and at the last 183. Okay, if you will calculate it, then you will get the total seek time. If you have to calculate 183 minus 0, 65 minus 0, this will be the seek time. Now C scan provides a more information waiting time than scan. The head moves from one end of the disk to the other, servicing request as it goes. When it reaches to another end or other end, however, it immediately return to the beginning of the disk. Okay, it will if it will be going to the other end, it will immediately return to the beginning of the disk without servicing any request on the return trip. Treats the cylinders as a circular list and wrap around from the last cylinders to the first one. So this is the C scan. Okay, and the queue has been started for that one, that is common, that is 98, 183, 37, 122, 14, 124, 65 and 67, and the head starts at 53. So as we have as I have told you that if it will be go start from this one and it will go into the end, and after the ending of the other hand, it will go to the first end. Means it will in the 199 it will go again to the 0, and then it will be start for the disk scheduling. So I am going to explain this one. The head is going to be 53, then 65, then 67, then 98, then 122, then 124, 183, and after that 183 the all values are in the right hand side, so it will end into the 199 and again it will be going to the 0. This is the main part of the C scan, and 0 to 14, 14 to 37. This is the most important part of the C scan, that if you have ended with one end, you have to go immediate to the first end. Then you go to the another queue part where it is given. If you will calculate it, it will be very easy to calculate your seek time, the latency time, all the times. But this is the most important part of the C scan. That is what, in the scan you are not going into the first end, you are moving from last to that values. But in the C scan you have to go from the first end to last end, or last end to first end. This is most important part of this scheduling algorithms. Now, what is C loop? It is a version of C scan. Arms only goes as far as the last request in each direction, then reverse direction immediately without first going all the way to end of the disk. Okay, means it is the last request in the each direction, then reverse direction immediately without going to the first end. Okay, as we have to the C loop. So for C loop, it is not going into the last part and the first part, the first end and the last end, that is 199 and 0. So it is going to the it is like a C scan, and the C loop is going to be walk on into this one, and for this you have to find the seek time 183 minus 53, and at the last you have to find 183 minus 37. This is the seek time for C loop. So for seek timing, we are going to be calculate the seek time. How we are going to do this one? So I am going to explain. So the head is started from 53. So as the 53 has been given, as a head started 53 to 65, 65 to 67, 67 to 98, 98 to 122, 122 to 124, 124 to 183, 183 to 14, because you can't go to the 37 part, because it will start from the last end point, first point. So, and that for 37, most of the student is asking that, sir, why we are not going into the directly to 37 and then 14? Because this is a C look type, and the C look means it will go into the one end to another hand, and so one end is 183 and another end is 14, because 183 is the nearest to the 199 and 14 is nearest to 0. So these two are the nearest part of the ending part. So we are going from one end to another end, and we are not supposed to cross the between in between them, because most of the students are doing these mistakes, that 183 to 37 and then 14. So it is the wrong way to calculate the seek time for C loop. Now, how to selecting a disk scheduling algorithm? SSTF is common and it is a neutral appeal. Means SSTF is a common and it is the neutral appeal for all the disk scheduling algorithm. Scan and C-scan perform better for the system that place a heavy load on the disk. Means if you are calculating, if you have given some task to the system and it will be a heavy load, then scan and C-scan will perform better for the systems. Performance depends on the numbers and the types of the request. Means the performance depends upon the numbers of the task what you have given and the type of request, what type of request you have given, priority based or non priority based, and anything more type of based request are going to be explained, and the performance will depends upon this one. Request for disk service can be influenced by the file allocation method. Request for disk scheduling algorithms are influenced by the file allocation method, means where our file are be allocated and how I am going to be, or how the CPU is going to be access that files, and they have to do all the schedulings for this one. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if it's necessary. Means if you have to explain, the disk scheduling is very much separate module of operating system, because it is very much different algorithms from the CPU scheduling, from the process scheduling, and all this one. So for this one, this is the another methods for calculating the disk, and it is the most important part of the operating system. How to calculate the disks are going to be doing work by the seek time. Either SSTF or look is a reasonable choice for the default algorithms, because most of the default algorithms are having that work is going on to the very much part. So SSTF or look is the best choice, and you can say it is a reasonable choice for the all the defaults algorithms. So for the disk management, low level formatting or physical formatting, divide a disk into sectors that the disk controller can read and write. Means for the low level formatting or physical formatting, we have to divide our disk into the sectors, and the disks are controlled and can be read or write. To use a disk to hold files, the operating system still needs to record its own data structures of the disk. To use disk to hold the files, operating system always have to need to record its own data structures for the disk. Partitioning the disk into one or more groups into the cylinders, logical formatting, or making a file system. Means if the disk has to, the operating system has to needs its own record, and it has to use its own data structure, so they have to part into the groups of cylinders or the number of cylinders, and they are making it the file system or not, and they are putting into the cylinders or not. They have to how to read, they and when to read, and when to write, and when to update. Boot block initialized system. The bootstrap is stored in ROM, random only memory, read only memory. So the bootstrap is stored in the ROM, and bootstrap loader program is also initialized by the disk management. Methods such as sector sparing used to handle bad blocks, means that there are very much sector sparing which are used to handle the bad blocks. Now this is the one part that I have took, that is MS-DOS disk layout. So this is the part of the disk layout where the MS-DOS is going to be work. So these are the sector 1, sector 0, sector 1, sector 2. These are the sectors in the disk. So sector 0 is stored in the boot blocks, sector 1 is the fat blocks, and sector 2 you can say, or the various sectors, root directory and data blocks or subdirectories. In the data blocks, all the data are stored in this one, which are the data structures are going to be used to arrange the values or arrange the files or arrange the CPU schedulings algorithms they are doing in this one. So the root directory is that, what is the root directory, what to call into the root directories. These are the method whereby we are going to be used in the root directory. Fat are the those files where we can't change, these are the ROM files where we can't change, and the boot blocks store the operating systems, all the files, that one. This is the MS-DOS disk layout. So if you will see, for the disk scheduling, there are much cylinders over there, and there is a part where you have the head, and the head will rotate and rotate, and the head will count which file they have to read, which file have to write, and these all are into the cylinder parts. The all are into the cylinders, if you will see into it. In the next lecture or in the next video lectures, I will explain what is the file management and how the disk is going to be stored. So in the today's videos, I have told about you the disk schedulings, algorithms, and disk management. So the disk schedulings, what is the disk scheduling, how we have major component, what are the access timing for the disk scheduling, and what are the major components of the disk scheduling, and what is the disk bandwidth, I have told you, and what is the disk scheduling. So for from where we are going to be do, and this is the first algorithm, first come first serve, how to calculate the seek time. I have given you this one overview, and this is the SSTF, shortest seek time first. For this shortest seek time first, I have told you how to calculate the seek time, and for the shortest seek time first, which is nearest to your head, it will go into that one. So this will be the shortest scan. It is also called the elevator algorithms. How to calculate the scan, how to go to the disk scheduling for the scan, I have also explained this one. C scan, what is the C scan, how it is different from the scan, and how it is going to be calculate from one end to another end, I have told you this one also. C look, this is a version of C scan, and how it is going, it will be going to the last version to first version, means last point, that is 183, which is nearest to 199, and then 14 because it is nearest to 0. So this is the scan and C look or scan difference. How we are selecting the disk scheduling algorithm, SSTF is neutral, and how SSTF and look is reasonable choice for this one, and when the scan and C scan is better, I have told you this one also. And what is the disk management, how we are managing the disk, we are doing this. And what is the MS-DOS disk layout, I have explained the boot blocks, fat, root directory, and the data blocks. So in the next video, I will explain all the file management systems and the deadlocks. Thank you so much.